Hi, everyone. So it's Mr. Webster here, and I'm going to walk you through Unit 2, Lesson 2, which is about a subject called molar mass. So just a quick reminder about the first lesson is that we introduced the concept of the mole, and we use the mole basically, the mole is a word that represents a number, just like a dozen. So a dozen, if I told you, if I asked you, how many is in a dozen, you would say there are 12. In a mole, it's this huge number, 6.02 times 10 to the 23. So these are words that represent numbers. And the reason why chemistry needs a concept like the mole is that atoms and molecules are so small that we want to talk about them in terms of moles, rather than always using these huge numbers and saying, oh, we have 6.02 times 10 to the 23 of them. I can now say that I have 1 mole of them. And so that's what we wanted to get from lesson 1. Well, now we're going to start dealing with the subject of mass, because oftentimes you're given the masses of things, and we'd like to know how mass and moles are related. So that's what today's lesson is about, is how are mass and moles related. Well, I want to start off with an analogy. And so that's my goal in the next little bit. If you don't want to take notes on this, you don't have to. You can just listen along. And hopefully this analogy will help us when we return to the concept of chemistry. So here's my analogy. So first off, if I asked you how many is a dozen, you would tell me, well, that's easy, Mr. Webster, it's 12. So if I said, go get me a dozen donuts, you'd get me 12 donuts. If I asked you to get me a dozen pens, you'd come back with 12 pens, and so on. But then if I asked you the question, how much does a dozen weigh? I think you'd look at me and be a little bit puzzled. And you'd say, well, it depends. You would say, and I would say, well, what do you mean? What does it depend on? And you'd say, well, it depends on what you're dealing with. If it was, a dozen donuts, a dozen donuts, you might say it weighs, I don't know, 500 grams. I'm not sure what a dozen donuts weigh. Or you said if it was a dozen cars, they obviously weigh a lot more. So how much does a dozen weigh? Well, you'd say it depends on what? Depends on what you're dealing with. Okay, so that's going to be an important concept. When I ask you, and in a little bit, I'm going to ask you what a mole weighs, your first question should be a mole of what? So a mole of carbon weighs different than a mole of copper, just like a dozen donuts weighs different than a dozen cars, obviously. Okay, well, let's, again, take this analogy one step further. Let's say I told you that a dozen basketballs weighs 2.21 times 10 to the 3 grams. Now, I'm going to use scientific notation here, just because we've got to start getting used to scientific notation. But a lot of you will say, well, Mr. Webster, that's just 2,210 grams. And you're right. And we know that there's 1,000 grams in a kilogram, so technically that's 2.21 kilograms. Okay, well, regardless, I've told you that number. So a dozen basketballs weighs that. A dozen soccer balls weighs 1.44, and tennis balls, ping pong balls. I can give you a dozen of anything. But in those cases, I've told you, okay, well, I've given you the mass of a dozen. All right. Well, let's do some calculations with this. And again, I think that it's going to be important for you to I'm going to take this analogy to chemistry in a second, but I think it's important for you to see what I'm talking about. So if I asked you what was the mass of 2.3 dozen soccer balls, well, you would say, well, I know what a dozen soccer balls weigh. A dozen weighs this. And so 2.3, I would go, okay, well, 2.3 times 1.44 times 10 to the 3 grams. And then you would say, well, that's, and if you type that into your calculator right now, it would say 3,312 grams. So what you did there was you took the number of dozen, and that was given to you, and you multiplied it by the mass of 1 dozen, which you also knew. And when you got that, that gave you the total mass. Okay, so I think that's fairly reasonable. Well, what if I asked you as my second question, if I said, well, if you have 10 kilograms of basketballs, how many basketballs would you have? Well, this is a little bit different. This is a little bit different in that now I've given you the mass, the total mass. Well, first up, I know what 1 dozen basketballs weighs, and it weighs 2,210 grams, or 2.21 kilograms. So if I have 10 kilograms, I'm going to take the 10 kilograms I have, and I'm going to divide it by that 2.21 kilograms that I saw above, because that's the total mass I have. And I'm just going to write this here. That's the total mass divided by the mass of 1 dozen. Okay, and when I do that, when I divide those numbers, I get 4.525 approximately. And so that tells me I have that many dozen basketballs. Because again, there's my total mass, that's the mass of a dozen of them, 2.21 kilograms, so that's how many dozen I have. So notice that I have turned a mass into a count, because remember, dozens are a count of them. And I can then say, well, it did ask me how many basketballs, and didn't say how many dozen basketballs, so then I would just take that 4.525 and I would multiply it by 12, because I know that there are 12 in a dozen. And when I do that, I would get approximately 54 basketballs. Now, there is a decimal that goes with that, but obviously you can't have part of a basketball, so maybe there was some error somewhere. But I think a pretty good estimate is I would have 54 basketballs. Okay, so I've used a mass to go back to a count. And I did that by knowing this really important number here, and I'm just going to circle it. This number was the mass of a dozen basketballs. Okay, so I can use that to help me out. I'm going to take this analogy one step further before we go back to chemistry. And I'm going to make this make-believe thing up, and it says, we call it a combi ball. And a combi ball is made up of 1 basketball and 2 soccer balls. Okay, so it's this funny looking ball that has 1 basketball and 2 soccer balls attached to it. I don't know what it would look like. I don't know, it would look something like, maybe like this. Okay, it's this weird looking ball. But it says, what is the mass of 3.6 dozen of these things? And I'd go, okay, well, I know that for basketballs, I know a basketball, I know that each dozen basketballs weighs 2.21 times 10 to the 3 grams. And in a combi ball, there's 1 basketball. So I'm going to multiply it by 1, and I get 2.21 times 10 to the 3 grams. And I know for soccer balls, they weigh 1.44 times 10 to the 3 grams. But in every one of these combi balls, there are 2 of them, so I better multiply it by 2, and I get 2.88 times 10 to the 3 grams. And when I add those up, I get 5.09 times 10 to the 3 grams. So 1 dozen of these combi balls, which they've given this little symbol, and you can see that obviously they're trying to compare this to chemistry. 1 dozen of those weighs 5.09 times 10 to the 3 grams, because it's made up of one basketball, and 2 soccer balls. Okay, so I know what a dozen of those weigh. Well, but it's asked me, well, what would 3.6 dozen weigh? Well, okay, well, I'm just going to do what I did in the first example. Well, I know that 3.6 times 5.09 times 10 to the 3 grams, and when I do that math, I get approximately 18,324 grams, or 1.83 times 10 to the 4 grams. So your calculator, if you type that in, would probably show 18,324, but I can turn it back into scientific notation by just moving the decimal place. Okay, so that's just an analogy, showing that we can move back and forth between counts and masses. Well, now let's go to chemistry. And just remember, it says here, a dozen is a number that has been given a name. The same can be said for a mole. The only difference is that the number defined as 1 mole is quite large. So just like in the analogy, I asked you how many is a dozen, and you told me a dozen was 12. Well, how many is a mole? Well, a mole is 6.02 times 10 to the 23. That's how many it is. When I tell you to go get me a mole of donuts, you're going to go get me 6.02 times 10 to the 23 of them. Well, then I say to you, well, how much does a mole weigh? Well, again, I want your answer to that question to be a mole of what? A mole of what? Because a mole of donuts weighs more than a mole of cars. And a mole of copper atoms weighs more than a mole of carbon, and I'll show you why. So where do you find, or how do you find how much a mole of something weighs? Well, this is really neat, because what it turns out is that the atomic mass given on the periodic table is not only the mass of one atom of that element, but it's also the mass in grams of 1 mole of that element. So this is really cool. When you look at the periodic table, and I'm just going to jump to my periodic table right now. When you look at the periodic table, and I look at carbon, and carbon shows me that it's 12.01. Well, 1 atom of carbon weighs 12.01, what we call atomic mass units, but also 1 mole of carbon weighs 12.01 grams. So not only is it the mass of an atom, but it's also the mass of an entire mole if you put grams with it. So your periodic table is going to become very important in the next little bit as you want to calculate what the mass is of 1 mole of things. So the mass of 1 mole of carbon atoms is 12.011. Well, we can extend that now to get the mass of what the mole of a compound is. So listen to this. Here's calcium nitrate. In calcium nitrate, there's one atom of carbon. We have that 2 applies to everything in the brackets, so there are 2 atoms of nitrogen, and then 2 times 3, there are 6 atoms of oxygen. So if I want to figure out what 1 mole of calcium nitrate weighs, I've got to work with each of those atoms separately. So the first thing I would do is I would look up on the periodic table the mass of calcium, and sure enough, I would get it's 40.08 times 1, because there's only one atom in calcium nitrate. Then I would go to nitrogen, and I'm just going to quickly look over at my periodic table, and nitrogen I see is 14.01. And so I'd go 14.01 grams for every mole, and there are 2 of them. And so I can see that that's going to be 28.02 grams per mole. And then for oxygen, I would look it up, Look over to my periodic table. Oh, oxygen's a nice one. It's 16.00. So I go back and I go, it's 16.00 grams per mole times 6. Okay, let me go to my calculator and I'll type that in. 6 times 16, and I get 96. Okay, so it's 96 grams per mole. And then all I got to do now is add those up. And so it's 40.08 plus 28.02 plus 96. Here we go. Plus, I've already forgotten. Let me go back and look. 40.08 and 28.02. 40.08 plus 28.02, is that it? 164.1. 164.1 grams per mole. So every mole of calcium nitrate, 1 mole has a mass of 164.1 grams per mole. So look at that. We can calculate the mass of 1 mole of anything. Okay. Well, now what I want to do is look at some other calculations we're going to do with the molar mass. And again, we're going to look at our hub. And in this particular case, we're interested in the top right-hand corner of our hub. And I hope you guys have a copy of the hub that I gave you. And if not, I'm going to put a copy of it in this lesson so that you can see it. But essentially, we've got another triangle. But first of all, let's define our variables. So again, we know that little n is the number of moles of a substance. So that's the number of moles. We know little m. We're now going to define that as what we call the sample mass of the substance. And then this capital M is the molar mass. So that's what I just calculated there was 164.1 for calcium nitrate, or it could be 12.01 for carbon. But those are the three variables that we're going to use in this lesson. Now, again, we've got a triangle, and the triangle technically gives us 3 different formulas. All you've got to do is cover up what you're looking for, and then it'll give you how you calculate using the other 2 variables. So if I cover up little n here, I know my formula becomes the sample mass divided by the molar mass. If I cover up the sample mass, little m, I get a formula of n times capital M. And I would never really cover up capital M because I know that capital M always comes from the periodic table. If I ever want the molar mass of something, I use the periodic table to calculate it. I'm going to go to the periodic table and get that number. Okay, well, let's try a couple questions here. So this question says, find the mass of 1.34 moles of calcium chloride. All right, well, let's use our problem-solving technique of given. So I've been given this 1.34 moles, and I need to attach a variable to it because I know that in order to use my hub and use my equations, I need to know what letter that represents. Well, again, the unit normally gives it away, and because it's moles, it's a little n. So I've been given my little n, and then I've been given the compound, and the compound is calcium chloride. Well, as soon as you're given the compound, using your periodic table, you can go and calculate the molar mass. So I the capital M, and I'm going to do CaCl2 is equal to. Well, there's 1 calcium there, so 1 times, and I go to my periodic table. Here we go. My periodic table for calcium, it's 40.08. 1 times 40.08, I got that number from the periodic table, plus there are 2 chlorines there, so 2 times, go to my periodic table, and it's 35.45, 2 times 35.45, and then I add those 2 up. Here we go. I get, I'm just going to use my calculator on my phone rather than going back and forth to that online calculator. So here we go. I'm doing it on my phone right now. So I go 40.08 plus 2 times 35.45, and I get 110.98 grams per mole. Okay, so technically I've been given that. Now, my required in this case is it says find the mass. Well, that's the sample mass. So the little m is equal to a question mark. Okay, I need a formula. All right, well, I know my triangle. I know my triangle is little n, little m, and capital M. And again, you've always got that in front of you because you'll always have your hub with you on any quizzes or tests. So here we go. Little m is equal to n times capital M. So the number of moles times the molar mass. And so I'm going to sub and solve into that. And it's going to be 1.34 times 110.98. And when I plug that in, I'll just do it on my calculator in front of me here. 1.34 times 110, and I get 148.7 grams. Okay, so we're using our knowledge of what the molar mass is, and we get the mass. Okay, well, let's try another question here. And this one says, a bottle contains this number of grams of potassium nitrate. How many moles do you have? All right, well, again, let's write down what we've been given. I know that I've been given 45.3 grams, and I've got to attach either a little n, a capital M, or a little m to that. Well, I know that it's not moles because obviously the unit tells me grams is not the unit for moles, so it's not little n. And because I know that capital M comes from the periodic table, I know that I must have been given a sample mass, so a little m. Little m is equal to 45.3. The required, it says, is how many moles? Oh, so that's little n is equal to question mark. And now another thing that I've been given is I can go to the periodic table and calculate the molar mass of KNO3 or potassium nitrate. So here we go. It's going to be 1 times the mass of potassium. So I'll look up potassium. Potassium is 39.1. 1 times 39.1 plus, and there's 1 nitrogen, 1 times, look it up, nitrogen is 14.01. 1 times 14.01 plus, and then there are 3 oxygens, so 3 times 16. Okay, and let's add those up. I'm going to do those on my calculator. 39.1 plus 14.01 plus 3 times 16, and I get 101.11 grams per mole. So one thing I know right off the bat, if I only have 45.3 grams of it, I have less than a mole of it. Because if I had 101.11 grams, I'd have a full mole of potassium nitrate. So I know my answer is going to be a decimal. sometimes it's nice to begin with the end in mind. My formula is N is equal to the sample mass divided by the molar mass, so that's the A, and then I'm going to sub and solve into that, and so I go 45.3 divided by 101.11, that's grams, and that's grams per mole. And so when I divide that, I'm doing that on my calculator, 45.3 divided by 101.11, and I get 0.448 moles. Okay, so what I'd like you to do now is to do the homework questions I've said here. I'll just kind of go over a few of them with you. Some of them are pretty straightforward. It says state the molar mass of each element. So for that question, all you'd have to do is look it up on the periodic table. So for xenon, I would go to the periodic table and I'd find xenon. I see it down here in column 18. It's 131.29. And so it's 131.29 grams per mole. Every mole of xenon, every count of 1 mole weighs 131.29 grams. Okay, for number 24 here, you're going to have to do a little bit of math because it says find the molar mass of a compound. So for this one, for NH3, you'd have to do 1 times the mass of nitrogen plus 3 times the mass of hydrogen, and you'd get those two from your periodic table, and you'd get this. 26 has a little bit of a trick, is that they're finding the mass of an ion. Well, you know, you got this little +2 charge there. The charge makes no difference. And so here, that's just a little bit of a trick, is that all you do is 1 times the mass of copper. That little 4 here applies to the nitrogen, so 4 times the mass of nitrogen, and then 12 times the mass of hydrogen. So don't worry about the charge. Okay, so I'm going to leave that with you. Good luck, you guys, and I'll post the answers to those homework questions as well. And I've also put them in the slide. I just wanted to show you here, my last slide here, I do have the answers right here, so you can quickly double check whether or not you got them correct. Take care.